In this exercise, you'll learn how to use grading settings. Go ahead and open up your Grading-1 drawing in your tutorials folder, and then navigate to your tool space, and then click on the Settings tab. Next, right-click on Grading, and select Edit Feature Settings. In the Edit Feature Settings dialog box, expand the General section. I'm going to go ahead and move this column a little bit more. And then I want you to focus on the Save Command Changes to Settings portion. Now verify that this value is set to Yes. This setting saves command settings for reuse. Now, for example, if you create a grading and set the grade to 5%, then 5% is the default value the next time you create a grading. Go ahead and scroll down until you get to this section right here. And we need to maximize the grade, slope, and grade slope. Notice the options for the unit format and precision. The integer value for precision specifies the number of digits to the right of the decimal place. Go ahead and click OK. So that's how you go about reviewing grading settings in Civil 3D. In this exercise, you'll create a grading criteria set for a ditch grading. Then create 3 criteria in the set. Each grading criteria provides a standard formula for creating a graded slope. Individual criteria values can be locked so they cannot be changed for individual gradings. This exercise continues from reviewing grading settings. Now this exercise uses the Grading-1 drawing in your tutorials folder. Let's go ahead and go into your tool space and then click on the Settings tab. Next, expand your grading collection. Then expand the Grading Criteria Sets collection. The Grading Criteria Sets collection displays the existing grading sets for the drawing. You'll create a new grading criteria set when you create 2 new criteria within the new set. Right-click on the Grading Criteria Sets and click New. Now that we're in the Grading Criteria Set Properties dialog box, go ahead and enter in the following name. We're going to call this Ditch Criteria Set. Then as an option you can enter in a description. We're going to skip that and go ahead and click OK. Now you'll notice the new grading criteria set within the Grading Criteria Sets collection. Go ahead and right-click on our new criteria set and select New. We now have a Grading Criteria dialog box, and make sure you're on the Information tab. In the Name field, go ahead and type in the following: distance at -6%. This grading criteria creates a grade to a distance of 10 feet at -6% grade. Go ahead and click on the Criteria tab. Now type in the following parameters. We're going to leave the target at distance. We're going to specify that distance at 10 feet. For projection, we're going to leave it at slope. For format, we're going to change it to grade. And that grade will be -6%. And for the grade parameter, I'm going to check this little lock right here to go ahead and lock that. When you lock a grade value in grading criteria, you're not prompted to specify its value each time you use the criteria. Go ahead and click OK. Go ahead and expand your ditch criteria set and you'll see our latest. Let's type in a new one. Right-click on the criteria set again and select New. We're going to create a second criteria by repeating the previous procedure. However, we're going to use a different name. we're going to call this surface at 4:1 slope. Next, go to the Criteria tab. We're going to specify the target as surface. The projection we're going to leave at cut fill slope. For search order, we're going to leave it at cut first. Let's set the values for the cut slope projection going up and the fill slope projection going down. For each one, we're going to keep the format at slope, but the slope we're going to type 4:1. This criteria creates a grade to an existing surface at a 4:1 slope. Go ahead and click OK. Now for the third criteria set, right click and we'll add a new name. Relative elevation at 3:1 slope. And we're going to go to the criteria and set the following parameters. The target, we're going to change that to relative elevation. We're going to have a relative elevation of -3. The projection, we're going to leave it slope. For slope projection, we're going to leave the format at slope. But we're going to change the slope to 3:1. This criteria creates a grade to a relative elevation of -3 feet at a 3:1 slope. Go ahead and click OK. So that's how you go about creating grading criteria in Civil 3D. In this exercise, you'll create a new grading style and slope pattern. This exercise continues from creating grading criteria. Now note that this exercise uses the grading-1 drawing with the modifications you made from the previous exercise. So let's start by going to the Tool Space and then click on your Settings tab. Expand your grading collection and then expand your grading styles. Select your grading styles collection, right click and select New. Now we're in the Grading Style dialog box. Make sure you're on the Information tab and then type in the following name. We're just going to call this Ditch, and optionally you can add a description. Next, click on the Display tab. We're going to change the color of the daylight line. We do that by clicking this box right here, and we're going to change it to red. Click OK. Now click on the Slope Patterns tab. Under Options, go ahead and check the box for Slope Pattern. Now it's currently on Basic. What we're going to do is we're going to click this drop down and we're going to select Copy Current Selection. We're going to change the name to Ditch Slope and then go ahead and click the Layout tab. In the Component field, select Component 2. Now let's scroll down until we get to this section right here, Slope Line Symbol. We're going to change the symbol type to None. Now let's go ahead and click OK. Now as you can see, the new ditch slope pattern is selected for the ditch grading style. We can learn more about our grading style if we click on Summary and expand this information. As you can see, under the slope pattern style, we have it set to ditch slope, which we just created. Next, go ahead and click OK. Now if we go into our tool space under the Settings tab, we can expand our general settings, expand multi-purpose styles, and then select slope pattern styles. And the style that we just created for our ditch shows up right in this section here. So that's how you go about creating grading styles in Civil 3D. In this exercise, you'll use two different methods to create feature lines. Feature lines can either be drawn with straight and curved feature line segments, or created from existing alignments, or AutoCAD lines, arcs, polylines, or 3D polylines. A feature line can be used as a grading baseline, but not as a target. This exercise continues from setting up grading standards. We'll begin by creating feature lines from AutoCAD objects. Now note that this exercise can use the Grading-1 drawing with the modifications you made in the previous tutorial. Or you can open up the Grading-2 drawing, which is located in your Tutorials folder. We'll go ahead and begin by drawing a couple lines that connect circles A, B, and C. We'll do that by going to the Home tab, and then over to the Draw panel, click the line drop down, and select Create Line. Go ahead and zoom in and snap to the center of A, and then connect this line to B, and then over to C. Go ahead and press Enter to exit the command. Now go over to the Home tab again, and then to the Create Design panel. Select the Feature Line drop-down, and select Create Feature Lines from Objects. Our command line is asking us to select a line, so we'll select this one and this one. Go ahead and press Enter. Now we get the Create Feature Lines dialog box. These feature lines will be contained within Site 1. And notice that you can also assign a name to each of these lines. Naming significant feature lines can make it easier to assign targets when creating a corridor. For this exercise, though, you'll assign the names after the feature lines have been created. Following the workflow enables you to create many feature lines at the same time, but only the most significant feature lines. Go ahead and keep everything else at its defaults and click OK. You'll see when you click on each of the lines that they are in fact feature lines, and they're all contained within our Site 1. If you click on feature lines, you'll see them listed down below. But notice that the name fields are blank. Let's go about naming our feature lines. Go ahead and select each one, then right-click and select Apply Feature Line Names. We get our Apply Feature Line Names dialog box. Go ahead and select this button right here. Now we'll name our template. Within the property fields, we're going to leave it on Next Counter and then click Insert. Then within the name box, type in A, B, C. And I'm going to go ahead and put a space. Then click OK. Then click OK. Now you'll see that the name fields are still blank. What you want to do is you want to click on Feature Lines, right-click, and select Refresh. Now the appropriate names are shown for our feature lines. Next, you'll draw a feature line and specify elevations along the line. Let's go about drawing a new feature line. Go into your Home tab, and then to your Create Design panel again. Click the Feature Line drop-down, and select Create Feature Line. We get our dialog box again. Our feature lines are going to be contained within the Site 1, but now we're going to check the name box. And then we're going to replace feature with C, D, E, F. because we're going to be connecting C, D, E, F. Now under Style, we're going to leave that checked, but we're going to change it to Ditch. Go ahead and click OK. Now our command line is asking us to specify a start point. Go ahead and select the center of C, and now it's prompting us for an elevation. Go ahead and type in 688. Now specify the next point within D, and for this elevation we're going to specify transition to defer entering elevation values at intermediate points along the feature line. Go ahead and select the center of E and select transition again. Pan up and then select F. But for F, we're going to select the surface. Now the surface elevation in this area is 712.066. Go ahead and accept that elevation by pressing Enter. Go ahead and press Enter to end the command. Now you'll see that this ditch is also shown within our feature lines, and it's labeled accordingly with the appropriate style. So that's how you go about creating feature lines in Civil 3D. In this exercise, you'll assign elevations to the feature lines you created from AutoCAD lines in the previous exercise. This exercise continues from creating feature lines. So let's go about editing feature line elevations. Now note that this exercise uses the Grading-2 drawing with the modifications you made in the previous exercise. We'll start by going to the Modify tab and then over to the Edit Elevations panel. Then select the Elevation Editor. Our command line is asking us to select an object. Let's zoom in and select our ditch feature line. In the Grading Elevation Editor, you'll see the length of each leg of our feature line, as well as the elevation at each vertex. Notice that as you specified in the feature line exercise, the elevation of 688 and the elevation of the last point, which matches our existing surface of 712.066. The elevation values of the two intermediate points are interpolated based upon your beginning and end point values. Now you'll assign elevation values to line AB. Let's go ahead and pan over to feature line AB. Then select this button right here to select the feature line. Go ahead and select feature line AB, and you'll see how our Grading Elevation Editor changes. In our Grading Editor, we're going to select this button, Insert Elevation Point. Now we're going to select a point somewhere midway between A and B. In the Insert PVI dialog box, we can specify an exact station and elevation. But for right now, just go ahead and click OK. You can see how it added that additional PVI. The point is added to the table where you can edit the station, elevation, length, and grade. Go ahead and press Escape and select the feature line. Now go ahead and click on that PVI that you created, and you can stretch it along this line. Notice how the elevation doesn't change. If I move it to this side, the length changes, but the elevation stays constant. Let's go ahead and set our elevation by double-clicking on the field, and we're going to set the elevation to 687. In the next few steps, you'll drape feature line BC across the existing ground surface. This command assigns an elevation to each vertex on the feature line. So let's go about draping a feature line on a surface. If necessary, press Escape once or twice to deselect feature line AB. In the Modify tab, go ahead and go into the Edit Elevations panel and select this button, Elevations from Surface. Now we get the Set Elevations from Surface dialog box. We're on our existing surface, and under Options, we want to make sure that this box is checked to Insert Intermediate Grade Points. And for Relative Elevations to Surface, we want to keep that cleared. Go ahead and click OK. Now you can go ahead and select the feature line BC, and then press Enter to exit the command. If we select it and right-click and select Elevation Editor, you'll see all the data for that feature line, including each elevation that passes the edge of a triangle of a tin surface. You can also see those designated by each of these circles. A feature line on a surface like this can be a useful starting point for a grading. You can use controls along the top of the Grading Elevation Editor to add or delete elevation points and to adjust their elevations. You can select multiple points by holding down Shift and raise and lower them together. Go ahead and select the checkbox to close the editor and go under Surfaces. Right-click on your existing surface, go to Surface Properties, go into Information, and turn on the triangles for our tin lines. Click OK, and if you select the feature line, you can see where all of these cross. So that's how you go about assigning feature line elevations in Civil 3D. So in this exercise, you'll create a set of gratings called a grading group. These form a runoff on the side of an embankment. This exercise continues from assigning feature line elevations. So let's go about creating a grading group and specify grading creation settings. Now note that this exercise can use the Grading-2 drawing with the modifications you made in the previous exercise, or you can open the Grading-3 drawing from your Tutorials folder. So let's go ahead and start by clicking on the Home tab, and then look within the Create Design panel. Then select the Grading drop-down and select Grading Creation Tools. We'll get the Grading Creation Tools toolbar, and the first thing we'll do is select this button, Set Grading Group. We get the Create Grading Group dialog box, and we're going to give it a name. We'll call it Ditch Drainage. We'll select the box for Automatic Surface Creation, and then the surface style, we're going to leave it on Standard. For the Volume Base Surface, we'll check that box. Then we're going to select OK. Now we get the Create Surface dialog box. We're going to keep everything at its defaults and then click OK. Now go back into your toolbar and then select this button, Select a Criteria Set. We can select a ditch criteria set and then click OK. You'll notice after doing that we have a list of different criteria. We're going to go ahead and select distance at 6%. Now it's time to create our grading. Select this button right here and then zoom in to the feature line that's connecting A and B, which is this white line right here. Now our command line is asking us to select the grading side. We'll select this side right here, and we're going to apply to the entire length of the feature line. So click Yes. Now for the distance, we're going to leave it at its default of 10 feet. So we'll just press Enter. Escape out of the command and then select this little diamond, which will allow us to select the entire grading. You'll see after creating this grading that if we go under Sites and under Site 1, you'll see our ditch drainage grading group. This grading creates one side of the ditch extending down from the baseline at 6% for a distance of 10 feet. After selecting the grading object, go into your properties and select a different style. We're going to select the ditch style, and you'll see how that changes the appearance of our grading. In the next few steps, you'll create another grading from the target line that was created from our previous grading. This grading will connect to our existing surface. So let's start by zooming out until we see both A and B. We'll begin by selecting our grading criteria. We'll change it from the 6% to the 4:1. Go ahead and click your grading button and then select the feature line, which is going to be right here. And we're going to apply to the entire length. It's asking us for our cut slope of 4:1. We'll select Enter, and our fill slope will be 4:1. Press Enter. Go ahead and press Escape to exit the command. So the grading is created. This grading creates a 4:1 slope from the bottom of the ditch to the surface. Now note that your results may differ from the illustration. So that's how you go about creating a grading in Civil 3D. In this exercise, you'll edit the elevation of a grading baseline. The grading adjusts to reflect the elevation change. So let's go about editing the feature line elevations. Go ahead and open up your Grading-4 drawing, which is located in your Tutorials folder. This drawing contains a white rectangular building pad. If we select it, you'll see that it's a feature line with specific elevations assigned to it. This building pad is graded to the surrounding surface at a 3:1 slope, which is represented by this grading. Where the slope pattern is green, it's a fill slope, which the grading slopes down from the grading pad. Conversely, the red area is the cut, which the grading slopes up from the building pad. Go ahead and go into your Modify tab, and then over to the Edit Elevations panel, and click on the Elevation Editor. Our command line is asking us to select an object. Go ahead and select the building pad. The Elevation Editor shows the grading settings for each corner of our pad, as well as some intermediate points. In the Elevation Editor, go ahead and shift-click the 3rd and 4th rows. We're going to change these elevations to 730. You'll see how our grading is now affected, particularly the cut. The grade back and grade ahead values have also changed. Now let's edit the feature line grades. Go ahead and shift-click the first 4 rows. Now go ahead and click this button to flatten grade or elevations. We're going to make this into a constant grade. So now all of these are at a constant slope. Next, select this button. Show grade breaks only. The second station row is now hidden, as you can see here, because there's no difference in grade between it and the previous station. In the first row, Let's change this by double-clicking the box and type in -3%. Go ahead and select this button again. Notice that the second station grade has changed to reflect the change that you made in the last step. Go ahead and select the checkbox. So that's how you go about editing the grading elevation in Civil 3D. In this exercise, you'll adjust the elevation of a building pad to balance the cut and fill volumes. This exercise continues from editing the grading elevation. So let's balance cut and fill volumes. Note this exercise uses the grading-4 drawing with the modifications you made in the previous exercise. Or you can open up the grading-5 drawing, which is located in your tutorials folder. We'll start by going to the Analyze tab and then over to the Grading Volume Tools. We get our little window right here. Now on the Grading Volume Tools toolbar, notice that when we select the grading group, it's currently on Building Pad, which is really the only grading group within our drawing. Go ahead and cancel out of this. The fields for cut, fill, and net show that the grading as designed requires the net cutting and removal of a large volume of surface material. I'll select this button to raise the grading group. Now, note the changes within our volumes. You'll see within the description that the group was raised by 1 foot. You can also select this other button to lower the grading group. And you'll see that we're right back to our original cut, fill, and net volumes. Lastly, go ahead and select this button to automatically raise or lower to balance the volumes. In the Auto Balance Volumes dialog box, leave the required volume set to 0. Or you can change the value if you wish, but go ahead and select OK. When we move this off to the side, you'll see that the net volume has been adjusted as close as possible to the set value. So that's how you go about balancing cut and fill volumes in Civil 3D. In this exercise, you'll edit a grading criteria and an associated grading adjusts to reflect the criteria change. You'll edit grading criteria attribute values in 2 ways. In the Elevation Editor dialog box, using this method updates the grading criteria for only the currently selected grading object. The second way to edit criteria attribute values is to actually go into the settings. This method will apply the attribute changes to future grading objects created with the criteria. If the attribute value is locked, attribute changes will also be applied to grading objects that currently use the criteria. This exercise continues from balancing cut and fill volumes. It also uses the grading-3A drawing, which contains 2 grading groups that use the same grading criteria. So let's go about editing the grading criteria. Go ahead and open up your grading-3A drawing, which is located in your tutorials folder. Now go ahead and click on the Modify tab, and then under the Design panel, go ahead and click Grading. Next, select the Grading Editor. Now you'll see within our command prompt, it says to select a point in the grading. We're going to go ahead and zoom into this green one right here, and inside the diamond, go ahead and click. And then up pops our grading editor. Under the grading method, under distance, we're going to change this to 5. Notice that the grading updates to reflect the change. Now you'll make a similar change that will affect all grading groups using the distance at -6% grading criteria. Now go into your Settings tab, and then under Grading, we'll maximize grading criteria sets, and make sure that your ditch criteria set is maximized, and select the distance at -6%. Right-click and select Edit. We get our grading criteria dialog box, and we're going to move this off to the side so we can see our drawing a little bit better. Make sure that you're on the Criteria tab, and under Grading Method and Distance, we're going to change this from 10 to 20. Press Enter, and then we're going to lock this criteria. This locks the attribute value, which will apply to all grading objects that currently use the distance at -6% grading criteria. Leaving this value unlocked applies the value to only grading objects that are created in the future. Go ahead and click OK. Now when we zoom out, you'll see how all of these grading objects are both updated in the drawing to account for the new criteria value. So that's how you go about editing the grading criteria in Civil 3D. In this exercise, you'll use the Feature Line Stepped Offset command to generate a simplified footprint from which to grade. The drawing you'll use in this tutorial displays a building pad, as you can see in blue. And this building pad is displayed in two vertically arranged viewports. In the right viewport, the building pad is shown in Plan View. You'll design the building pad in the right viewport. However, the left viewport, the building pad is displayed in Model View. You'll use this viewport to see the status of the design as you work. Let's go ahead and create a stepped offset feature line. We start this by opening up our Grading-6 drawing, which is located in your Tutorials folder. Next, within the command line, type in offset gap type. Then press Enter, and make sure that the value is set to 1, which it currently is. Then press Enter. The offset gap type variable controls how potential gaps between segments are treated when closed polylines, such as the building pad feature line, are offset. Setting this variable to 1 fills the gaps with filleted arc segments. The radius of each arc segment is equal to the offset distance. Go ahead and go to your Home tab. Then to your Create Design panel. Select the Feature Line drop-down. Then select Create Feature Line from Stepped Offset. On our command line, it's asking us to specify offset distance. Go ahead and type in 1.5 as the distance. In the right viewport, click the blue feature line that represents the building pad. Click outside of the building pad when prompted to specify the side to offset. Now our command line is asking us to specify an elevation difference. Go ahead and type in G for grade, then enter -1 for the grade. Press Enter. Now if we zoom in, you'll see that the stepped offset feature line is displayed. Notice that in the left viewport, on the left side of the ramp, this curve wasn't created properly. Because it's an independent feature line, you can use the feature line editing tools to refine the solution. Go ahead and go up to the Modify tab, and then over to the Edit Geometry panel. Select this button right here to fill it. Now our command line is asking us to select an object. I'm going to go over to the right viewport, click on it, and select this outer feature line. Now it's asking us to specify a corner. We're going to specify a radius, and we're going to type in 15. Let's go ahead and zoom out a bit, and you'll see that when we click each of the sharp corners, you'll see a little preview of our ramp. Click that corner, and then click this corner. You'll see another preview. So the fillet is applied to the feature line. I'm going to go ahead and press Escape to exit out of the command. Do that a few times. Now the fillet is applied to the feature line, and in the left viewport you'll see how smooth everything is on both sides. It also interpolates the elevations along this curve. So that's how you go about simplifying a building footprint in Civil 3D.